Imagine a world subtly wrong, a place where the familiar becomes unfamiliar, where the ordinary twists into the extraordinary. Picture walking through a city you know well, yet every corner, every shadow feels just a bit off. The buildings stand tall, but their reflections in the glass seem to ripple and distort, as if reality itself is bending, a place where everything looks familiar, yet feels strangely off. This is not a dream or a figment of imagination, it is a glimpse into the realm of antimatter. Here the rules of our universe are mirrored, creating a world that is both a reflection and a distortion of our own. This is the realm of antimatter, a mirror image of our own universe, where particles exist with opposite charges. In this strange and fascinating domain, every particle of matter has a counterpart, an antiparticle, with the same mass but an opposite charge. When these particles meet, they annihilate each other in a burst of energy, a dance of creation and destruction that is as beautiful as it is deadly. Antimatter is not science fiction, it's a scientific reality. Researchers at institutions like CERN have been studying antimatter for decades, unlocking its secrets and uncovering its mysteries. The discovery of antimatter has revolutionized our understanding of the universe, challenging our perceptions of reality, and opening up new possibilities for exploration and discovery. It's a concept so profound, so mind-bending, that it challenges our very understanding of the cosmos. The existence of antimatter forces us to rethink the fundamental nature of reality, to question what we know about the universe and our place within it. It is a reminder that the cosmos is far more complex and mysterious than we can ever imagine. Antimatter holds within it the potential for unimaginable power. The energy released when matter and antimatter collide is immense, far greater than any energy source we currently possess. This power could revolutionize our world, providing a nearly limitless source of energy that could transform our technology, our society, and our future. A power that could fuel starships and unlock the secrets of the universe. Imagine spacecraft powered by antimatter, capable of traveling vast distances at incredible speeds, opening up the cosmos for exploration and colonization. The dream of interstellar travel, of reaching distant stars and discovering new worlds, could become a reality with the power of antimatter. But this power comes at a price. The same energy that makes antimatter so powerful also makes it incredibly dangerous. The annihilation of matter and antimatter releases a tremendous amount of energy, enough to cause catastrophic destruction if not carefully controlled. The potential for disaster is immense and the risks are high. Antimatter is also the universe's most dangerous substance, capable of unleashing unimaginable destruction. A single gram of antimatter could release as much energy as a nuclear bomb, making it a powerful weapon in the wrong hands. The challenge of harnessing antimatter's power safely and responsibly is one of the greatest scientific and ethical dilemmas of our time. For decades, scientists have grappled with the mysteries of antimatter. They have sought to understand its properties, to unlock its potential, and to find ways to produce and store it safely. The quest for antimatter is a journey into the unknown, a voyage of discovery that pushes the boundaries of human knowledge and ingenuity. Why is it so rare? Despite its potential, antimatter is incredibly scarce in the universe. The reasons for this scarcity are still not fully understood, and solving this mystery could provide crucial insights into the nature of the cosmos and the origins of the universe itself. How can we harness its power? The challenge of producing and storing antimatter is immense, requiring advanced technology and innovative solutions. Scientists are exploring new methods and techniques, pushing the limits of what is possible in their quest to unlock the power of antimatter. The answers to these questions could rewrite our future among the stars. The successful harnessing of antimatter could lead to technological advancements beyond our wildest dreams, transforming our world and opening up new frontiers for exploration and discovery. Join us as we delve into the heart of antimatter, exploring its incredible properties, its potential, and the profound implications it holds for the destiny of humanity. Together, we will journey into the unknown, uncovering the secrets of the universe and unlocking the power of the cosmic mirror. To understand antimatter, we must first understand the building blocks of our universe: matter. Matter is the substance that makes up everything we see and touch. It's the foundation of all physical objects, from the smallest grains of sand to the largest galaxies. Without matter, the universe as we know it wouldn't exist. Matter is all around us, from the air we breathe to the stars in the night sky. It's in the food we eat, the water we drink, and the ground we walk on. Every object, living or non-living, is composed of matter. This omnipresence of matter is what makes our world tangible and real. It's made up of tiny particles like protons, neutrons, and electrons. These particles are the building blocks of atoms, which in turn form molecules, the basic units of chemical compounds. The interactions between these particles and the forces that govern them are what give matter its properties. Each of these particles has a specific charge. Protons carry a positive charge, electrons carry a negative charge, and neutrons are neutral, meaning they have no charge. The balance of these charges within an atom is what keeps it stable and allows it to interact with other atoms. Protons are positive, electrons are negative, and neutrons carry no charge. This simple yet profound difference in charge is what makes the structure of matter possible. The positive charge of protons and the negative charge of electrons create an electromagnetic force that holds atoms together. Antimatter, as its name suggests, is the opposite of matter. While it might sound like something out of science fiction, antimatter is very real and plays a crucial role in our understanding of the universe. It's composed of antiparticles, which are identical to their matter counterparts in every way except for their charge. It's composed of antiparticles, which are identical to their matter counterparts in every way except for their charge. For instance, an antiproton has the same mass as a proton, but carries a negative charge. This means that while they are similar in many respects, their opposite charges make them fundamentally different. For instance, an antiproton has the same mass as a proton, but carries a negative charge. This opposite charge is what defines antimatter and sets it apart from regular matter. The existence of antimatter was first predicted by physicist Paul Dirac in 1928, and it has since been confirmed through various experiments. Similarly, an anti-electron, also known as a positron, has the same mass as an electron, but carries a positive charge. This discovery was groundbreaking because it showed that every particle of matter has a corresponding antiparticle. The positron was the first antiparticle to be discovered, and it opened the door to a new understanding of the universe. These differences in charge are crucial. They are not just theoretical concepts, but have practical implications in the world of physics. The interaction between matter and antimatter is one of the most fascinating phenomena in science. When a particle of matter meets its corresponding antiparticle, they annihilate each other, releasing a tremendous amount of energy. They are the key to understanding the incredible energy released when matter and antimatter meet. This annihilation process is not just a destructive event, but also a source of immense energy. Scientists are exploring ways to harness this energy for practical uses, such as in medical imaging and potential future energy sources. It's a meeting that results in the ultimate annihilation. The study of matter and antimatter not only helps us understand the fundamental nature of the universe, but also holds the promise of revolutionary advancements in technology and energy. As we continue to explore these opposites, we unlock new possibilities and deepen our understanding of the cosmos. When matter and antimatter collide, the result is an event of unparalleled violence. Annihilation. The two particles cease to exist, their mass converted entirely into energy. This energy release is far greater than anything achievable through nuclear fission or fusion. It's the purest form of energy conversion, governed by Einstein's famous equation E equals mc squared. Imagine a single gram of antimatter. Annihilated with an equal amount of matter, it would release the energy equivalent of a nuclear bomb. The power locked within antimatter is staggering, making it a tantalizing, albeit dangerous, prospect for future energy production. This incredible energy release is why antimatter has captured the imaginations of scientists and science fiction writers alike. It holds the potential to power starships, fuel entire civilizations, and perhaps even unlock the secrets of the universe itself. Section 4. The mystery of the missing antimatter. The laws of physics suggest that the Big Bang should have created equal amounts of matter and antimatter. This fundamental principle is rooted in the idea that for every particle of matter, there should be a corresponding particle of antimatter. These pairs should have been produced in equal quantities during the universe's inception, leading to a perfect balance. Yet, when we look out at the universe, we see a clear dominance of matter. Galaxies, stars, planets, and even life itself are all composed of matter. The observable universe is overwhelmingly made up of matter, with antimatter being conspicuously absent. Antimatter is exceedingly rare, found only in trace amounts in high-energy cosmic rays and certain types of radioactive decay. These fleeting glimpses of antimatter are not enough to account for the vast quantities that should have been produced during the Big Bang. This imbalance, known as the matter-antimatter asymmetry, is one of the most profound mysteries in modern physics. It challenges our understanding of the fundamental laws that govern the universe, and raises questions about the very nature of reality. Where did all the antimatter go? This question has baffled scientists for decades. If matter and antimatter were created in equal amounts, why do we see such a stark imbalance today? Why does the universe seem to prefer matter over its mirror image? This preference is not just a minor quirk. It has significant implications for the structure and evolution of the cosmos. These questions have puzzled physicists for decades, leading to a relentless search for answers. Researchers have dedicated their careers to unraveling this enigma, conducting experiments and developing theories to explain the matter-antimatter asymmetry. Theories abound, each attempting to explain this cosmic imbalance. Some suggest that during the early moments of the universe, certain processes favored the production of matter over antimatter. These theories often involve complex interactions between particles and forces that are not yet fully understood. Some suggest that subtle differences in the behavior of matter and antimatter in the early universe led to a slight excess of matter. These differences, though minute, could have been enough to tip the balance in favor of matter, leading to the universe we observe today. Others propose the existence of exotic particles or forces that favor matter over antimatter. These hypothetical particles and forces could have played a crucial role in the early universe, creating the conditions necessary for the dominance of matter. The answer, when we find it, will have profound implications for our understanding of the universe's origins. It will not only shed light on the events that shaped the cosmos, but also deepen our comprehension of the fundamental principles that govern existence. The quest to solve the mystery of the missing antimatter continues to drive scientific inquiry, pushing the boundaries of our knowledge and inspiring future generations of physicists. Section 5. The Quest for Answers. Scientists are engaged in a multi-pronged quest to solve the mystery of the missing antimatter. Particle accelerators, like the Large Hadron Collider, smash protons together at near-light speeds, recreating the conditions of the early universe. By studying the debris from these collisions, researchers hope to find clues about the behavior of matter and antimatter in the universe's first moments. Other experiments focus on creating and trapping antimatter here on Earth. Creating antimatter is no easy feat. It requires enormous amounts of energy and sophisticated equipment. Once created, antimatter must be carefully contained, using magnetic fields to prevent it from coming into contact with matter and annihilating. Despite the challenges, scientists are making progress. They've successfully created and trapped antihydrogen atoms, the antimatter counterpart of hydrogen. These achievements bring us closer to unraveling the secrets of antimatter and its role in the universe.